Module 2, Lesson 12, Relationships between two numerical variables. I can determine if a scatter plot has a relationship and if it is linear. Open your workbook to page 59. Example 1, looking for patterns in a scatter plot. The National Weather Climate Data Center collects data on weather conditions at various locations. They classify each day as clear, partly cloudy, or cloudy. Using data taken over a number of years, they provide data on the following variables. X represents elevation above sea level in feet. Y represents mean number of clear days per year. W represents the mean number of partly cloudy days per year, and Z represents the mean number of cloudy days per year. The table below shows the data for 14 U.S. cities. Here is a scatter plot of the data on elevation and mean number of clear days. So it's elevation, which would be X right here, elevation above sea level, and then Y, the mean number of clear days per year. When you do your assignment today, you're actually going to be using this same table. However, you're going to be using X, the elevation above sea level, and W, the mean number of partly cloudy days. So you'll actually be using this for X and this column right here for Y, and you'll be making your own scatter plot. So just a heads up on the homework that you'll be using those two columns. Okay, so this scatter plot here uses the first two columns. First question, exercises 1 through 3, says, do you see a pattern in the scatter plot, or does it look like the data points are scattered? Okay, I actually see a pattern. To me, it looks like, as I look at the graph from left to right, that the points are going in an upward trend. So I would say yes. Let's see what the rest of the questions say. It says, how would you describe the relationship between elevation and the number of clear days for the 14 cities? So I'm going to elaborate on this question a little bit more, since they didn't ask what I wasn't sure exactly what they were going to ask. So I'm going to say yes, there's a pattern, and I'm going to say it looks more like a positive linear pattern. Okay, so the next question says, how would I describe the relationship between the elevation and the mean number of clear days? So we're looking specifically at elevation and mean number of clear days. That is, does the mean number of clear days tend to increase as elevation increases, or does the mean number of clear days tend to decrease? So I'm going to go with, since it's a positive pattern, I'm going to go with that they're both increasing. So as the elevation increases, the mean number of clear days increases. You should make sure when they ask you to describe a relationship between two things that you actually state what those two things are in your sentence. And if it's a positive, both things should be going up. And if it's negative, one thing should go up and the other thing should go down. And then it says, do you think that a straight line would be a good way to describe the relationship between the mean number of clear days and the elevation? So in other words, they're basically asking us if we think it's a linear relationship, and I would say yes. And why do I think that? I think that all the points look like they would fit better with a line as opposed to a curve. Okay, moving on. So exercises 4 through 7, thinking about linear relationships. Below are 3 scatter plots. Each one represents a data set with 8 observations. Okay, so there's 8 points on each. That's what the 8 observations mean. There's 8 points on each graph. The scale on the x and the y axes have been left off these plots on purpose. So what they mean is they didn't put any numbers on the x and the y axis. They left them off on purpose. So you have to think carefully about the relationships. So they didn't want us to be led to believe anything specific. So it says, if one of these scatter plots represents the relationship between height and weight for 8 adults, which one do we think it is and why? Well, think about it. Height and weight for 8 adults. Which one do we think it would be? Let's move on and look at some of the other ones before we make a judgment. The next one says, if you think that these scatter plots represent the relationship between the height and the SAT math score of 8 high school seniors, which one do you think it would be and why? Okay, so this one, the first question is comparing a relationship between height and weight. The next one's comparing height and SAT math scores. And then number 6 says, if one of these scatter plots represents a relationship between the weight and fuel efficiency, which one do you think it would be and why? Thinking about that, which one do you think would represent height and weight, math scores versus height, and fuel efficiency versus weight? Okay, well in this one's clearly a positive relationship. That means both things are increasing. So this one's positive. Whereas this one's negative. Whereas this one here, they're kind of all over, the dots are all over the place, so this one is no relationship. So we have to think about is which one of these situations would be a positive, a negative, and no relationship at all. I think I've given you guys enough time to think about that. So for number 4, the one where both of them would increase, positive or a positive relationship, that would be number 4. As height increases, weight typically increases as well. Of course, you can always find people that are extremes, that are really tall, and don't weigh very much, or vice versa. Okay, but typically speaking, as a person gets taller, their height is going to increase also. So number 4, I would say, would be scatter plot 1. And the reason, again, in terms of putting that in writing, as a person's height increases, their weight is typically going to increase as well. Oops, I'll drop the T there. Okay, so then we have the one with no relationship and then the one that's negative. Well, usually the weight of a car is going to affect the fuel efficiency negatively. So 6 is going to be the one that is scatter plot number 3. Or excuse me, number 2. So usually as a car's weight increases, think of a little car versus a truck. Little cars get better fuel efficiency compared to a big truck. The fuel efficiency decreases. On the other hand, scatter plot number 3 is the one with no relationship. That's going to be the height versus the SAT scores. A person's height has nothing to do with what their SAT score is going to be. Okay? All right, the last question down here says, which of these scatter plots does not appear to represent a linear relationship? Okay, so does number 1 look like a linear relationship? I would say yes, this one's looking like a line. Plot 2, plot 2 is kind of looking like a curve. Obviously, scatter plot 3, there's no relationship. So I'm going to say scatter plot 2 is looking more like a curve than scatter plot number 1. So scatter plot 2 appears to have a curve in it. I'm going to say it compared to number 1. Okay, moving on. Exercises 8 through 13. Not every relationship is a linear relationship. And I think we've already been hinting at that. When a straight line provides a reasonable summary of the relationships between two numerical variables, we say that the two variables are linear related, or that there's a linear relationship between the two variables. Look at the scatter plots below and answer the questions that follow. So here's scatter plot 1. Is there a relationship between the number of cell phone calls and the age? Or does it look like the data plots are scattered? So you've got the age of people versus the number of cell phone calls that they make. Does it appear to be, according to the graph, does it appear to be a relationship? And I would say yes. If there is a relationship between the number of cell phone calls and the age, does it appear to be linear? And again, I would say yes, this appears to be a linear relationship. Later on in this book, we're going to talk a little bit about whether it's a strong relationship or not. A strong relationship is going to be close, what appears to be closer to a straight line. But anyway, that's not what we're talking about today. I would just say yes, it does appear to be a linear relationship. Looking at the next one, is there a relationship between moisture content and frying time, or does it appear that the points are scattered? Okay, I would say yes, moisture content is on the y-axis, frying time is on the x. Yes, there is a relationship. However, does it appear that it is a linear relationship? And I would say no to that. I would say there's a definite curve at the beginning. It starts up really high, then drops really quickly, and then curves. So I would say no, it is not a linear relationship. Okay, scatter plot 3 shows data for the prices of bike helmets and quality ratings. Based on the scale that estimates quality. Is there a relationship between the quality ratings and price, or are the data plots scattered? I would say this one's definitely scattered. That means that there's no relationship. Which means, it says if there is a relationship, does it appear to be linear? Since there isn't one, we cannot answer this question. Okay, so today's topic, I got to the beginning here. Today's topic was being able to figure out if a scatter plot has a relationship and if it is linear or not. Okay, and I think we talked about that already. We've hit the... So today's assignment, when you get that far, there is a typo in the book. First of all, the graph is really hard to read, especially on the y-axis, so you're going to have to make this fit. And then the table is missing. So when you get your assignment today, you're going to have to fix this particular problem up. It's for problems 5 and 6 in your assignment. And that is it for today's lesson.